Alright, class, as always, make sure that you are watching the correct video. This is Pre-Algebra Lesson 1.6, and it's Exponents. And so this is really the beginning of Chapter 1B. We split up Chapter 1 into two parts. So we finished Part 1, and now we're doing Part 2, and I'll just call it 1B. Alright, so 1.6 Exponents. So let's start off with some terms. So number 1, terms. It's important that you learn terms because I'll refer to them often, and you have to know what I mean and by what I say. So let's take our green. I'm going to put a green X. Then I'm going to take my red, and above and to the right and smaller, I'm going to write an A. So above and to the right and smaller. Okay, so we have X to the A power. The A is the exponent. The A is the exponent. I think you knew that. A lot of people don't know what the name of the X is, though. In other words, what the exponent goes to. And make sure that you know the X is called the base. So you have the base and its exponent. You have the base and its exponent. So A. The exponent indicates how many times, the base indicates how many times to multiply the base times itself. To multiply the base times itself. The exponent indicates how many times to multiply the base times itself. So I'm going to take my red here, and I'm going to underline exponent, then I'm going to underline how many times, and then I'm going to underline multiply. Okay? And then I'm just going to take and underline the base times itself. The base times itself. The exponent indicates how many times to multiply the base times itself. And this is very important. It's very important to always know what the base is. It's often the situation where students will get things incorrect because they will misapply the base. All right, we'll get there. Let's deal with a couple things first. So, example here. Let's continue with our color. I'm going to take my green and put a 5 in green. That's going to be our base. And I'm going to take my red and put a red 3 exponent. Again, exponents are always above and to the right, and they're usually a little smaller. Above and to the right, and they are usually a little smaller. Okay? Above and to the right, and usually a little smaller. Okay, so what is this saying? This says take the base and multiply it times itself 3 times. I'm going to use red here as my raised dots. So see how we have 3 5s, right? 5 cubed says do 5 times 5 times 5 3 times. Multiply the base times itself 3 times. It really doesn't matter the situation. Let's do another example here. I'll take my green again. Y to the 4th power. Y to the 4th power. So y is the base, 4 is the exponent. The exponent tells us to multiply the base, the y, times itself 4 times. 1, 2, 3, 4. And again, I'll go back and put in raised dots there. If I weren't doing it in color, I'd do it all at once, right? Y times y times y times y. Y times itself 4 times. Now, this is called expanded form. Right? When you write it out like that, it's called expanded form. We've expanded the base times itself as many times as the exponent says to do so. So those are called expanded form, and that'll come up at times. All right? Expanded form, and that will come up at times. Little b. All right, it's important to always understand this. If no exponent is shown, if no exponent is shown, if no exponent is shown, that implies the exponent is, and I'm going to finish in red. If no exponent is shown, that implies the exponent is 1. It's not shown, but the exponent is 1. Now that's going to come into play later on when we deal with some exponent rules. Okay? But everyone should understand that if the exponent's 1, we don't bother to write it. It's boring, but understand any number that does not show an exponent, the exponent is 1. Okay? C. Let's deal with situations where the base is negative. So C, a negative base. A negative base. Okay. When we have a negative base, there's the aspect of what is the exponent. The exponent can be either even or odd. Okay? Can be either even or odd. And so there are two possibilities with a negative base. And that's what we want to take a look at here, the two possibilities. So number 1, an even exponent. An even exponent. Okay, so let's do some examples and then I think you'll see how this happens. So an even exponent. So example. Something like this, when I'm going to use a parentheses, and I need to when I have a negative base. I'm going to put a negative 3 inside that parentheses, and I'm going to put a red 2 as the exponent. So we have negative 3 squared. Negative 3 squared. Okay, if I were to expand this, this says do the base times itself twice. So I have negative 3 times a negative 3. And of course, if I were to finish off and get the solution, negative times a negative is a positive, right? And then, of course, we know that 3 times 3 is 9, so the answer to that is 9. The answer to that is 9. So when we have an even exponent, in this example, we ended up with a positive product. Let's try another one here. And without doing too many, let's go ahead and do, how about a negative 2 base? And let's take that to the 4th power. Again, I'm using here even exponents, right? 2, 4, 6, 8, 10, etc. So only even exponents in this first grouping. So again, let's expand this. So I'm going to need 4 parentheses, right? Because I need the base times itself 4 times. So if we were to do this problem in an orderly fashion, the first thing we do is multiply these two together. Negative times a negative is a positive. 2 times 2 is 4, and that's a 4, right? And so now we end up with a 4 times the negative 2 times the negative 2. Next thing would be the next two things. Positive times a negative is a negative. 2 times 4 is 8. Now we have a negative 8. And again, that is now to finish off times a negative 2. Negative times a negative is a positive. 2 times 8 is 16. And notice again, we get a positive solution. So whenever there's an even exponent, that implies a positive product. Positive product. When you have a negative base, but an even exponent, you get a positive product. A negative base, you get a positive product. Okay, the second situation then is an odd exponent. An odd exponent. In this situation, it could be 3, 5, 7, 9, 11, etc. Right? So let's do the same thing. Let's do a couple examples. So I'm trying to keep my numbers from being too large. So again, let's go with a negative 3 base. And this time we'll take our red and make a red cubed. So we have negative 3 cubed. Negative 3 cubed. Okay, let's multiply the base times itself 3 times. So I'm going to do 3 parentheses. And each one is a negative 3, right? Negative 3 times itself once, negative 3 times itself twice, negative 3 times itself 3 times. Look what happens in this situation. Negative times a negative is a positive. 3 times 3 is 9. We have a positive 9. Now we still have times this negative 3. Now we end up with a positive times a negative, and that's a negative, and the answer is negative 27. What do you think is going to happen if I did the 5th power, or the 7th power, or the 9th power? In that case, the product is going to be negative. So an odd exponent implies a negative product. A negative product. Okay, now again, that's for a negative base, so you gotta be careful there. It's for a negative base. If it was a positive base, it's always positive. But a negative base, you have a couple possibilities, and so we need to be careful. A couple possibilities, and so we need to be careful with that. D. All right, so one other thing that I want to make you aware of right now while we're thinking about that is this. Let's do a blue negative sign. Take your red, or take your green, I'm sorry. Let's do a 5 base, so we have negative 5. And let's put a red exponent of squared. Okay. Now this is a very important problem. So let me show you something else. Let's go over here to the right, and I'm going to stick a negative 5 in parentheses and square it with a red tip. Okay. Now, are these exactly the same value? Well, be careful, because calculators tend to want to tell you that they're the same value. It all depends on how you punch it in. But these are two different problems. Can I tell you the first one is the same as this? I'm sorry, let me get my blue there. The first one is the same as this, a negative 1 times a 5 squared. So if we were to write this out, this would be a negative 1 times 5 times 5. And the solution to this would be negative 25. See, the exponent only goes to its base, what is directly below and to the left. That 2 exponent only goes to the 5. If the negative were to be included, we would have written it like that, right? The example on the right here. So you always have to understand. So in the example to the right, this is a negative 5 times a negative 5. And notice the answer here is positive 25. So you get a different solution. So be careful in those scenarios. The base being negative, there will be a parentheses. If there is no parentheses, that negative is outside, and you treat it as negative 1 times the base times itself that many times. Okay? All right, so let's go ahead and go to number 2. Number 2. Write, and now staying in blue, let's go 7, raised dot 7, raised dot 7, raised dot 7. There's 4 sevens. 7, raised dot 7, raised dot 7, raised dot 7 in exponent form. In exponent form. Okay, well, that's easy. What we have here is the base. So we're going to write 7 as the base, and we have to count how many times 7 is times itself. 1, 2, 3, 4. So 7 to the 4th power would be writing this in expanded form. Okay, 7 times itself 4 times. How about something like this? I'm going to use a variable. Remember, a variable is a letter to represent an unknown value. And let's suppose we had this. I'm going to go negative x, parentheses, negative x, parentheses, negative x. Okay, negative x, parentheses, negative x, parentheses, negative x. So what do we have? Our base is negative x. We have to maintain this parentheses, and it is to the third power. Okay, so technically that would be writing it exactly as you see it. However, we already learned that when there is a negative base and an odd exponent, the product is going to be negative. So on this one, we could finish it by really saying negative x cubed. They end up being equal and of the same value. Now again, that's only when there's a negative base to a odd exponent. Let's do another one. B. It can be blue. B. All right, here's one that's a little interesting. Let's go in parentheses. Let's go negative 2n, negative 2n, negative 2n, parentheses, negative 2n. So we have 4 of them. Negative 2n times negative 2n times negative 2n times negative 2n. So if we were to go straight forward, we would get negative 2n as the base to the fourth power. Again, we need that parentheses because the whole base is the negative 2n. Now, again, because we understand that a negative base to an even exponent is a positive product, we can write it without the negative and just do 2n to the fourth power. Those are equivalent. Okay, those are equivalent. Okay, so technically it's this way, right? But in reality, it's the same as that. We can write it that way. Again, those are a little tricky. Even and odd. You have a negative base and even and odd exponents. Okay, in time you get used to those. But be careful. Whenever they say write in expanded form, this is what we're looking for. Okay, that's expanded form. We're looking for you to write it out. And then, I'm sorry, in the exponent form. So if they say exponent form, we're looking for you to write it out. Okay, exponent form. We're going to do expanded form next. So exponent form, right? Make sure you write it out. And if you can simplify it, go ahead and do that. Number 3. Number 3. Number 3 is expanded form. Expanded form. Okay, so this is just the opposite. We're going to expand something, a base with this exponent. So A here, example. So suppose we had something like this, 11 to the third power. Usually we say that 11 cubed. It's the same as 11 to the third power. So again, we understand that an exponent tells you to multiply the base times itself 3 times, right? So this is going to be 11 times an 11 times an 11, right? 11 times an 11 times an 11. Let's do one with a negative base. Let's do a parentheses, negative 2. And let's go with the fifth power. Negative 2 to the fifth power. Okay, so if we were to expand this technically, it would be negative 2, parentheses times negative 2, times negative 2, that's 3 of them, times negative 2, that's 4 of them, times negative 2, that's 5 of them, right? Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times itself 5 times. But notice we have a negative base, right here, and we have an odd exponent right there, right? And a negative base with an odd exponent means that we're going to have a negative product. So there's another way you can write this if you understand what's going on. You could just simply stick that negative out in front of everything and then do the 2 times 2 times 2 times 2 times 2. Those are equivalent in value. This left one is really what's going on, and this right one is a simplified view of it. The left one is really the one that's going on, and the right one is simplified view. And you can do the same thing with a negative base and an even exponent. Let's do one of those. So how about negative 9 to the fourth? So technically, the base, negative 9 times itself, how many times? hopefully you're thinking 4. So negative 9 times negative 9 times negative 9 times negative 9. Now again, because we know that when you have a negative base and a positive exponent, that the product is positive, you could simply write it 9 times 9 times 9 times 9, because it's going to end up positive anyhow. Okay? Again, I know those are a little bit off the wall, but that is the way that those go, and that is the situation there. Okay, so that was exponent form and expanded form. To keep track of those, you're going to see them on homework, you're going to see them on quizzes, and you're going to see that on the test. Number 4. Now let's do some simplification. So simplify. Whenever you see the word simplify, we're trying to get a single numbered answer. Okay? Or we're trying to do as much math as we can. Okay? Trying to do as much math as we can. If you think of it that way, then you should understand the situation. So let's do a couple. A, 3 to the 4th power. So 3 with the base is 3, the exponent is 4. Okay, so your work on these, go ahead and expand it. 3 times 3 times 3 times 3. And how do you multiply? Well, you got to do two things together. So 3 times 3 is 9. You can also, if you want, do this 3 times this 3 and get 9. Final answer, 9 times 9, 81. Okay. All right, 3 times 3 is 9. 3 times 3 is 9. 9 times 9, 81. You could have also done it this way. You could have gone the more traditional route. Let me back it up, actually. Could have gone the more traditional route and said 3 times 3 is 9. You still have a times 3 times 3. Then do this 9 times 3 is 27. You still have times this 3. And now finally do 27 times 3 and you still get it to 81. Okay? Two ways of looking at the same problem. But again, to simplify means to expand it and then show a step or two of work there, show your work, and come up with that solution. Expand it, show your work, and come up with a solution. Let me show you another one, B. How about this? Parentheses, negative 2, close the parentheses, to the 5th power. So the exponent's 5. Negative 2 to the 5th power. Okay, because I remember that a negative exponent to a negative base to an odd exponent gives me a negative product, I can simply do this. I can put that negative out in front. Now again, if you don't remember it, just expand it the other way. And now I'll do 2 times itself 5 times. 1, 2, 3, 4, 5. So again, the traditional way, negative 2 times 2 is a negative 4. Right. Now this one is a negative 8. Now this one is a negative 16, and we bring down that other 2, right? And finally we get a negative 32, and that's the answer. And we're not going to give you a ton of these because, to show every step is time consuming, I understand, takes you a little bit of time. But you do have to get used to doing your work underneath. Notice that my work is underneath. What's under comes from what's above. Notice my work is underneath. What's under comes from what's above. This is a key concept in mathematics. This is a key procedure where you get used to the line below comes from the line above. And if you'll start putting this into practice, you'll really help yourself out tremendously. I'll mention it over and over and over again. All right, let's do another one, C. Look at this one. 3 cubed minus 2 to the 4th. Okay, let me first ask you this question. Is this negative sign part of the base with the 2? And the answer would be no. No. This problem is completely different. Don't write this. Just look from that. See, here the negative's part of the base. But in our original, it is not. This problem right here is a multiplication problem. Our problem is an addition problem. All right, well, let me show you the steps, and you'll see how we get there. So again, I'm going to work underneath, and I'm going to expand the 3 cubed. 3 times 3 times 3. Hopefully you agree. Now I still have this negative sign. It's just going to be sitting right there. And then I'm going to expand this 2 to the 4th. 2 times 2 times 2 times 2. All right, to keep it from being a zillion steps, we'll do 2 at once. 3 times 3 is 9. Oh, that should be blue. 3 times 3 is 9, and 9 times 3 is 27, right? Notice we still have this minus sign. All right, 2 times 2 is 4, times 2 is 8, times 2 is 16, and we end up with a 27 minus a 16. Final answer is 11. Final answer is 11. All right, you got to be careful with these. Look at this one, D. All right, you need a negative sign, a 5, and a squared, 2 exponent, negative 5 squared. Before I go any further, is the 5 part of the base? Yes or no? Answer, no. If it would have been, we would have put it in a parenthesis so you would know that. Because it is not in a parenthesis, that negative's not part of the base. Keep that straight. Let's continue, plus, and now we're going to use a parenthesis, negative 3, close the parenthesis, squared. Okay, let's expand it. We still have our negative sign, it's sitting there. Now I'm going to do this 5 squared, 5 times 5, right? Keep rolling along. I've got this plus sign, and let me expand the negative 3. Negative 3 times negative 3. Okay, so what's in front of the plus sign? What's this front end up being? And hopefully you say negative 25. We still got that plus sign. See how you do your work underneath? And what do we have on the right? Negative 3 times negative 3. Negative times a negative is a positive. 3 times 3 is 9. And we end up with positive 9. So we have negative 25 plus 9. All right, think about the answer to this. Okay, how do you do this one? Well, this is a 25 negatives and 9 positives. Remember, these 9 positives wipe out 9 of the negatives. Start counting from 9, count up to 25. How many is that? That's 16. And what were left? Positives or negatives? The one with the most? They were negatives, so hopefully you think that that's a negative 16, right? Start at the 9, count up to the 25, because again, those 9 positives wiped out 9 of the 25 negatives. How many negatives are left? 16. Answer, negative 16. Okay, it's a little tricky. See, you got to keep track of things. You got to be careful. Those of you that are not orderly, you're going to mess these up. Those of you that like to do your work in parts and little itty-bitty bits, you're going to mess things up. See how these plus signs and minus signs are continuing? You know, this one continues. Well, you do your work off to the side and you're going to miss all that stuff. So be careful, be careful, be careful. Procedure is important. Listen, what am I trying to do as a teacher? I'm trying to get you to pay attention to detail, right? Pay attention to detail. Those that don't pay attention to detail can struggle in their math. Unless you're a genius, and I hate to say it, class, but most of you are not geniuses, okay? So instead, we have to be orderly in what we are doing. Orderly in what we are doing. And so procedure helps. You've got to pay attention to detail. Pay attention to detail. Pay attention to detail. Let's go on. Number 5. Properties of exponents. Properties of exponents. Okay, you guys need to learn these right now. You need to learn them now so that you know them the whole rest of your math career. These properties of exponents come up all the time. All the time. So learn them now, and they'll be on just about every test the rest of your math career because you have to know these. Okay, the first one is the multiplication property of exponents. Multiplication property, we can abbreviate prop, of exponents. Multiplication property of exponents. Really, this is for when you have like bases. So let's take our blue. We're going to take a blue x and then our green and make an a exponent. So x to the a power. Take our blue again times x and then back to green again to the b power. All right, so let me let you see that and write that. X to the a times x to the b. Notice how they have the same base. They both have an x base. The first x has an a exponent, the second x has a b exponent. Okay, so what is the property? What does this equal? Well, I'm not going to tell you. I'm going to do an example. Let's see if we can figure out what this is going to equal. So let's come underneath and let's do example. Let's use, I don't know. Let's use the number 5. Oh, this should be blue. Sorry about that. So let's use the number 5, and let's go with 5 to the 2 power, back to blue, times 5, and let's go to the 3 power. Okay, so we're going to do this the long way. Our property is simply a shortcut. So the property is a shortcut. So let's do this long way. Let's expand this first one. What's 5 squared? 5 times 5. Let's expand this back one in black. What's 5 cubed? 5 times 5 times 5, right? 5 squared, 5 times 5. 5 cubed, 5 times 5 times 5. Now let's write our answer in exponent form. We have 5 to what exponent? 1, 2, 3, 4, 5 to the 5th power, right? 5 to the 5th power. So watch what happens. If I come back up here, if I knew the rule, I'd say this is 5. How do you get a 2 and a 3 to get to a 5? Watch, I'm looking at the exponents. How do you get a 2 and a 3 to become a 5? Well, I hope you said you get there by adding them. You get there by adding them. This is the rule. So let's go back up here. X to the a plus b power. When multiplying like bases, add their exponents. This is a shortcut. It saves you the time of expanding everything. And rightly so. Because if you were to expand everything, you'd be there forever. Let me show you what I mean. Let's do another example here. So here's how these would go. Let's suppose you had something like this. 7 to the 11th power times 7 to the 3rd power. Okay? What does the rule say? And by the way, I always want you to show the rule step. So we get 7 to the 11 plus 3 power. This right here is the rule step. Why do I want you to always show the rule step? Because I want you to remember the rule step. And every time you write it, you help your brain to remember it. So I always want you to write the rule step. Make sure that's part of your work. To be honest with you, normally we'll take that rule step and we'll stick it underneath, and I'll show you that in a minute. Instead of going to the right, we'll do all our work underneath, and so final answer 7 to the 14th. Okay? Make sure we show that rule step. Multiplication property of exponents. Let's do another example, same property here. Check this one out. Example. What if we had this 9 to the negative 7th power? You said, can exponents be negative? Yep. Times 9 to the 10th power. 9 to the negative 7th power times 9 to the 10th. Okay, let's just do our rule. They have the same base. Take the base and add the exponents. Take the base and add the exponents. 9 to the negative 7 plus 10 exponent. So what are we going to do? We're going to add up the exponents, right? 7 negatives and 10 positives leaves you 3 positives, 9 cubed. And if they wanted you to simplify, then you'd have to do 9 times 9 times 9. 9 cubed. Okay? And those are a little tricky. They're a little tricky, but that is the way that they go. Okay? A little tricky, but that's the way that they go. So this is a shortcut. So again, let me back up a second. I'm looking right here, right? When you have the same base, you're multiplying with the same base, you add the exponents. Multiplying with the same base, you add the exponents. Okay? B. Hang in there. I know this is a little bit of a long lesson, and that's why I designed it for at home. Power property of exponents. Power property of exponents. And I'll help you guys with all these when you're in class on Monday doing your homework. Okay? Power property of exponents. Okay, this one looks like this. Use the parentheses. We'll have an x. Take your red and put it to the a power. Go ahead and close the parentheses. Then take your red again and put it to the b power. So what do you have? You have two sets of exponents. You have the first exponent here, x to the a power, but then the whole x to the a power to the b power. Okay, this is an exponent to an exponent. Okay, how does this thing turn out? Well, again, we can figure this out by me showing you an example. So let's do an example. Let's go 3, and we're going to go 2 to the squared, so to the 2 power, and then take that whole thing and do it to the 3rd power. 3 squared cubed. 3 squared cubed. Okay, 3 squared cubed. Now, there's a couple different ways we can do this. Let's go inside and do this part first. Okay? So what is a 3 squared? A 3 squared is a 3 times 3, right? And we still have this thing cubed. Hopefully you agree, right? 3 squared is a 3 times 3, and it's all cubed. Now let's expand this, right? So what is our base? A 3 times 3, and do it how many times? 3 times. 3 times 3 times 3 times 3 times 3. All right. I have said that weird, but it's 3 times 3, 1 times 3 times 3 twice, times 3 times 3, 3 times. So if we were to write this in exponent form, what do we end up with? 3 to the 1, 2, 3, 4, 5, 6th power, right? 3 to the 6th power. So let's see if we can figure out the property. Let's go back to the original. Is there anything you can do with a 2 and a 3 to get it to be a 6? What can you do with a 2 and a 3 to get them to end up being a 6? Well, I hope you say you can multiply them, and that's exactly the rule. 3 to the 2 times 3, right? You multiply them. So let's go up and do it with the variables. What's the property? X to the a to the b equals x to the, use your red, a times b. I'm going to use my raised dot in green so it stands out. X to the a times b. That's the shortcut for exponents to exponents. X to the a times x to the b equals x to the a plus b. Again, this is a shortcut. It's a shortcut. It's a shortcut to save you time. Let's go off to the right. I'll give you an example. So let's suppose we had this problem. N to the 5th power, parentheses, to the 7th power. Now, if I wanted to write that all out, it's going to take me some time, but I don't need to. Because I know my rules, I know this is n to the 5 times 7 power. Again, this is the rule step. Make sure you show the rule step. Why do you show the rule step? Because you want to train your brain. Look, you can say in your head, let me go back here. You can say in your head, n to the 5 times 7 is 35. But you know what? Saying it in your head is different than writing it. It's a physiological fact. You'll remember things longer if you write them as well as think them. So I'm trying to get you to the place where you'll be most probability for success. So write the rule step. Final answer, n to the 35th. Okay, so the rule step is really your work in these. Your rule step would be the work in these, and that's the way they go. Okay, not a big deal. If it were numbers, let's do one more example with numbers. Let's go 3 to the 4th, all to the 5th power. 3 to the 4th to the 5th. Again, normally I'll do my work underneath. I'm going to show the rule step. 3 to the 4 times 5. My raised dot's in there. You really can't see it too well. Therefore, I end up with 3 to the 20th. Right now, we're leaving the answer in exponent form. 3 to the 20th. So that's the power property of exponents. Okay. We've got one more property, C. Division property of exponents. Division property of exponents. Division property of exponents. Okay, what does this one look like? X to the, and we're going to go green here, A, divided by, so we need a fraction bar, x to the, and let's go in green with the exponent b. Now we're dividing. X to the A divided by x to the b. And I'll give you this one. I'll show you why in a minute. But this equals x to the a power, the top power, minus the bottom power. X to the a minus b. X to the a divided by x to the b equals x to the a minus b. What is this rule? This rule is a shortcut. It's a shortcut to what's going on. I'll illustrate that with an example. Let's suppose I had this. 7 to the 5th power divided by 7 to the 3rd power. If I were to use the rule step would say 7 to the 5 minus 3 power, right? For a final answer of 7 squared. Okay, why is it 7 squared? Let me show you this exact same thing by expanding it. Okay, so let's take this exact same thing, 7 to the 5th divided by 7 cubed, and let's expand it. Okay, so what's our top? 7 times 7, 5 times, right? 7 times 7, 5 times. What's the bottom? 7 times 7, 3 times. Notice on the top is a 7 times 7 times 7. On the bottom is 7 times 7 times 7. What is anything divided by itself? 1. All of that equals a 1. Look what you're left with. Look what you're left with. 7 squared, aren't you? Yeah, you are. And that's how the rule works, and that's why the rule works. But we just use the rule. Pretty easy. We're just going to use the rule. Just use the rule. Just apply the rule to the situation, and away you go. All right, here's an interesting one. Example. Take a look at this one. How about this? X to the 5th divided by x to the negative 2. Whoa. There's a negative exponent again in the denominator. Hey, you know what? This is no problem. Let's follow the rule. X, top exponent, use your red here, minus bottom exponent, right? And normally we put this in a parentheses. Okay, class, let's apply some things we learned. Do you remember what minus a minus is? It's a plus. Where do we end up? X to the 7th power. Okay? Not a problem if we know how to apply the rule. X to the A over X to the B equals X to the A minus B. All right, I got to show you just one or two compound problems and we're done. So number 6, compound problems. These are tricky, but you can get them. You just got to do them in parts. Compound problems. All right, watch this. Give you 2 of them and we're done. Example. First example. Go parentheses z squared, close the parentheses, cubed, raised dot, z to the 5th power. We have 2 problems in one. Z squared cubed times z to the 5th. So watch. Here's one problem, an exponent to an exponent, and then there's going to be a second problem with multiplying like bases. So just like the order of operations, we're going to do this first one first. So set z, do you remember the rule? To the 2 times 3, right? Again, I'm showing the rule step. Now I still have the raised dot, and I still have the z to the 5th. Again, stay orderly, do your work underneath. Next step, z to the 6th times z to the 5th. Do you see now how we have a multiplying like bases? Again, show the rule step. This time you're supposed to add the exponents, right? Don't get your rules mixed up. Okay, and so our final answer, z to the 11th. Z to the 11th. Okay, just got to take it one step at a time. That's one situation. And again, these can come in varying different situations. Let me show you one more. Last example. Sorry for the length of this. I know it's a little long, but this is important stuff, and this will allow me to help you guys with all these problems in class on Monday, okay, instead of making you go home and try to do them all. All right, so here we go, B. X to the 5th times x cubed. X to the 5th times x cubed. Okay, so we have x to the 5th times x cubed. Then we're going to use a, we're going to use a division symbol. So x to the 5th times x cubed divided by, and then we're going to go parentheses x squared parentheses cubed. Again, x squared parentheses cubed. Okay. Well, again, we have 2 compound problems. We can do this part first, right? X to the A times x to the B equals x to the A plus B. That's that one. Rule step again. Still have my division symbol. And now we can do this one as well. X to the A to the B equals x to the A times B. Multiply the exponents. All right, let's simplify. Let's simplify. So this is an x to the 8th divided by an x to the 6th. Now, if we change form to fraction form, x to the 8th divided by x to the 6th, now we remember the division rule, right? So finishing this up, x to the numerator's exponent minus the denominator's exponent. And so our final answer, x to the 8 minus 6, is x squared, and that's the problem. All right. Again, you can go back and watch this again. You can rewind, and you can do all of that. These are, again, this is an important aspect. Your exponent rules come up the whole rest of your math career. So this will be on the internet now forever. So you have problems with your exponents, go back and look at this video and refresh your memory. But you got to get this stuff down. You got to get it down. This is important stuff. All right, thank you. Have a good night.